As the number currently stands, only about 550 people have ever been to space, ever since Soviet cosmonaut Yuri Gagarin became the first to do so in 1961. We've obviously made a lot of progress in spaceflight ever since then, even if we don't have moon colonies and huge space stations yet. But our only real method of getting people or cargo into orbit still rely on crazy expensive and inefficient chemical rockets which need a lot of fuel. And this means that the vast majority of every single rocket we've ever built has to be dropped off and, in most cases, effectively wasted, reducing what was this upon launch to this upon re-entry. Now, we could build rocket stages that can safely land themselves to be recovered, which would help a lot, but what if there were a better way to get to space? Well, first, before we get to know how we can improve on classic chemical rockets, we need to talk about how to get to space in general. Or rather, how to stay in space. Getting into space isn't actually all that hard, relatively speaking. All you really need to do is fly above 100 kilometers altitude, and you're now in what we generally agree to be space, even though there isn't actually a clear boundary between the atmosphere and space, but still. But since gravity doesn't just cancel out at the edge of the atmosphere, the real problem is that once you do fly up to this altitude, still not exactly the easiest thing to achieve, you're just gonna fall back down to Earth. While getting to space is still hard enough on its own, staying in space for longer than a few minutes is what really eats up a rocket's fuel. As in order to achieve a stable orbit at an altitude of, say, 200 kilometers, a spacecraft needs to accelerate to nearly 7.8 kilometers per second, fast enough to get from New York to London in under 12 minutes. That's why rockets need to carry so much fuel. As a result of this, launching basically anything into space is prohibitively expensive. Never mind any discussions on safety, rather dampening our ability to expand into space. But what if there were a way to not have to drop any stages at all? What if we could launch something in only a single stage to orbit? SSTOs can come in a variety of forms, usually either in the form of airplanes that have rocket engines and can therefore propel themselves further in the vacuum of space, or rocket stages that can launch themselves into orbit and then deorbit themselves to be safely recovered. Now, technically it isn't actually required that an SSTO be recoverable, but given their application in spaceflight, it's kind of an unofficial requirement. Now, chances are you might have actually heard of the abbreviation SSTO before, possibly through the video game Kerbal Space Program. SSTOs are relatively easy to make in Kerbal Space Program, but the problem with this is that Kerbal Space Program is full of lies. Or, not really, it's just set in a very different star system from our own. Why'd I write full of lies in the script? The reason it's so easy to make an SSTO in Kerbal Space Program is because, for a variety of reasons, the planets in the Kerbal system are extremely small. While spacecraft orbiting Earth need to stay above 100 kilometers and orbit at around 7 to 8 kilometers per second, on Kerbin, the in-game analog for Earth, they only need to fly above 70 kilometers and fly at 2 to 3 kilometers per second, thus requiring way less fuel for stable orbit. So, not lies, but do keep in mind that just because something works in Kerbal Space Program doesn't necessarily mean it'll work in Human Space Program. SSTOs have a myriad of problems though. First, they can't drop any used tanks, which is of course the easiest way of lightening the load upon launch. Maintaining as light of a load as possible is quintessential to any launch, as the more mass you add, the more fuel you need to transport that mass, but the more fuel you add, the more mass the rocket gets, and the more mass the rocket gets, the more fuel it needs, until eventually adding more fuel barely does anything at all. This is the tyranny of the rocket equation, and staging helps somewhat to alleviate this problem, as well as allowing spacecraft to use different rocket nozzles at different altitudes. You see, rockets work differently depending on the air pressure around them. At sea level, for instance, where the pressure is highest, more narrow nozzles work best for providing thrust, whereas in the high atmosphere in space, larger thrusters generally perform the job better, getting the exhaust pressure to match the pressure of the surrounding gas. It's obviously not that simple, but basically, a nozzle that works perfectly fine at sea level will become very inefficient once you reach the higher atmosphere. And if that nozzle isn't as efficient anymore, well, guess what? That's a lot of dead weight you're now carrying along. And when it comes to spaceflight, every kilogram counts. Now, perhaps there's a more efficient fuel source that we could use in the future for launches, but what if we could circumvent rockets altogether? What if we had true, solid infrastructure in place for getting us into orbit? Well, quite a few ideas have been made over the years, all with varying amounts of lunacy. Probably the most famous of these ideas is the space elevator. So first, to give some background, the higher up from a body you orbit, the slower you go and the longer the orbit takes. At 400 kilometers altitude, the International Space Station orbits once every 90 minutes, while at 400,000 kilometers, the moon takes more like 29.5 days. At about 35,000 kilometers altitude though, an orbit takes roughly 24 hours, which allows a spacecraft to stay above a single point on the equator. While orbiting Earth specifically, this is called a geostationary orbit. And some have proposed putting something heavy, like a small asteroid, in this orbit and attaching it to the ground with a giant tether, creating a space elevator and using the Earth's spin to easily and cheaply put you into orbit. Well, once it's built at least, because remember, this cable needs to be almost as long as the Earth's circumference. And we would need a strong enough material to make sure the whole thing doesn't snap in some admittedly fun to watch fashion. And whatever we use for the climber, we would also need a way to power it on its way up, a journey which could potentially take hours or even days. Great idea, but would take a lot of effort to pull off. A similar idea to the space elevator, but one that might actually be easier to construct, is the skyhook. Imagine a long tether, but this time only about 1,000 kilometers long, not 35,000, far below a geostationary orbit. Put this construct upright relative to the ground, and it can act as a kind of mini space elevator for ships that catch up to it, at least for going from lower orbits to higher orbits, though do also watch out for that Newton's third law thing. If we spin it though, it could allow for a craft to go from flying within the atmosphere at merely supersonic speeds, to orbiting high above the Earth at speeds possibly high enough to go to the moon, or even escape Earth's orbit entirely. It would almost be like a space elevator, given that the lower end, although not stationary, would still be traveling at speeds we could at least manage compared to orbital velocity. Kurzgesagt and Isaac Arthur go into far more detail about this concept, but it's one idea that could potentially make it easier for us not just to get into orbit, but also become an interplanetary species. StarTram would also be a gigantic structure, but one entirely on Earth. StarTram is essentially a giant maglev tube gradually increasing in height until you're at a high altitude and are traveling very fast, like at least on a suborbital trajectory. So your craft would still need fuel to complete the orbit, but nowhere near as much. Make this tube 1,500 kilometers long and end at a height of 20 kilometers, a height we've admittedly never built to yet, and you've got yourself a launch loop, or a Luftstrom loop. Or, you know what? How would you just like to be shot into space in a cannon? You wouldn't survive the journey, but the epically named Space Gun, or Vern Gun, is the oldest of all these ideas, though it does at least have some more modern designs to it. Said designs would be only used for cargo, what with all the high G-forces involved, though this is how the characters in Jules Verne's From the Earth to the Moon get from the Earth to the Moon. However, you would have to accelerate something to much faster than orbital velocity to get through the lower atmosphere, assuming the payload wouldn't burn up in said lower atmosphere. Something like this, however, could potentially be used on the moon, where there isn't an atmosphere and it takes a lot less velocity to get into orbit or escape entirely, possibly even going back down to Earth, which would definitely come in handy if you wanted to start some sort of lunar mining business. But maybe what this shows is that the real problem was launching from sea level in the first place. We could launch something from atop a mountain like Mount Everest or the equatorial Chimborazo, but those peaks are extremely difficult to access, at least when it comes to setting up a spaceport. We've all seen those videos of people sending things to the edge of space with weather balloons. So what if we attached a rocket to a balloon and launched it from there? Sure, it would still need to gain that 8 kilometers per second of speed, but it wouldn't have to go through as much of the atmosphere. Now, when you combine rocket and balloon, you get Raccoon, presumably because Ballot was already taken. A Raccoon was actually designed and tested in 1949, though these tests did expose some issues with the concept, notably the fact that balloons can't be easily steered and rely heavily on the weather. More recently, however, many a startup has started to adopt the idea for launching small CubeSats, though scalability is still a bit of a problem here, so it remains to be seen whether we can make a balloon big enough to launch a rocket big enough to launch a human into space. I mean, we probably could, but what I'm really asking here is, would that be worth our while? At least compared to the other designs here. Of course, no one ever said that getting to space would be easy at first, so it's no surprise at all that these ideas may seem a bit out of reach for us as of yet. But do keep in mind that we're the species that is spread all across the Earth's landmasses, travels between said landmasses like it's nothing, builds ski slopes in the Arabian desert, and, oh yeah, voluntarily straps ourselves into repurposed nuclear missiles with the slim hope of going to the moon and kicking death in the ass on the way up. and we've done it 6 times. So yeah, I think we got this. Thank you for watching this essentially pilot episode of Celestium, a new channel that I'm doing so I can talk about space and science topics that I can't normally talk about on my other channel, Khanubis. If you like this video and want to see more like this in the future, you can of course like, share, and subscribe to catch more in the future. I don't have any schedules or slogans for this channel yet, so I'm just gonna stand here until the video ends.